The last class we have studied what is differential pulse code modulation. Now in this session we will be studying a different flavor of PCM called as delta modulation. This delta modulation is extremely important because it is widely used because of its applications, and you need to study this in practicals also the coming lessons. What is delta modulation? What the incoming message signal is oversampled, a rate much higher than the Nyquist criteria to increase the correlation between the adjacent samples of the signal. So what is delta modulation? In delta modulation, only the difference in polarity is being encoded as the output. That means that we have a high oversampled signal, and within the adjacent pulses only the difference in polarity is being encoded and transmitted. Okay, so here the difference between the analog input and the feedback signal, if it is positive, it is taken as 1, otherwise it is taken as 0 and transmitted as a 0 voltage pulse. So what happens? Only the polarity of the different signal is encoded as the output. So working principle, how a delta modulator works. So in the transmitter multiplier, one input is a periodic train of unipolar pulses, very small pulses, and the other one is the output of a comparator. Okay, the comparator is having two inputs, M of t and M dash of t. Here you are checking the difference in polarity using an integrator. Okay, and the output of this is fed to the comparator as a feedback signal, that is called as M of t. So that only the difference, so you get, we call it as delta modulation, we'll have it as a step function, right? The polarity is positive if the analog signal M of t is greater than and is negative if it is less than the feedback signal M of t. So you are comparing these two signals. If it is greater, it is positive, otherwise negative. In differential pulse code modulation, what we did was we transmitted only the difference between the two adjacent signals. Here, what we are doing is that we are sensing out the amplitude and pulse and the difference between the pulses is being recorded as a digital value, and only this is being transmitted. The difference between DPCM and delta modulation I will explain to you in the coming slide, where I will be explaining to you with the help of a graph. Delta modulation has higher resolution. It means that even for a small change in input value, it responds in a much better fashion than any other kind of modulation. And delta modulation has wide applications. So among the drawbacks, the notable drawbacks of delta modulation is that if the amplitude varies to a great extent, when the things are large, change in amplitude is higher, you will have large errors. So this is how the process of delta modulation works with a time period, and let us consider a grid graph like this. Whenever there is any change in data, you can note that all these values are 1. Here it comes to become 0, 0, 0, 0, 0, and 1 depending upon the change. So the entire process of delta modulation is explained in this graph with time and amplitude. Okay. This is a block diagram of a delta modulation system. You have an analog signal which you are giving it to a comparator, and you have a staircase maker here. Staircase will give you an output like this. This could be a question in your exams. Very oftenly asked. Every question paper had one question on delta modulation. This is a block diagram of a delta modulation system, transmission system. The next slide, I'll explain to you the receiving part of delta modulation. So in the receiver's end, the digital data is received, fed to the staircase maker through the delay unit, low pass filter, and you get the analog signal in the end. Just the reverse process of the so delta pulse code modulation, or another one, it is not differential. DPCM is delta here. There is a small difference between delta modulation and delta PCM. Instead of using one bit to indicate positive or negative differences, we create a symbol. A symbol means a set of bits, and that would be the difference in quantization. Each bit code is used to represent the value of difference. And this is done only to improve the accuracy. The only thing what we are doing is we are improving the accuracy by converting that one bit into a symbol where it has more number of bits. So different data transmission modes. You have parallel, serial. In serial you have asynchronous, synchronous, and isosynchronous data transmission modes. So with this, we have come to the conclusion of the third module. And these are your assignment questions. You can either write it down now or you can copy it from my you'll be having around 12 questions. You need to submit these 12 questions by next Friday. Okay.